Okay, math application students, we're going to talk about exponential growth and decay, and we're going to talk about applications of this. So here's an example. If I've got y equals some number x to the power of x, here I can demonstrate that on my calculator, 3 to the power of x. Okay, and then if I want to get a graph of that, my graph has this kind of shape. Okay, I'm just going to draw the shape. The numbers are not so important right now. Okay, and it looks like that. And what if I had, what if this number was less than 1? So I'm going to do second delete to insert, and I'm going to type in 0.3. Okay, so if I got 0.3 to this power, let's see, how does the graph change? Notice the graph looks like that. And when the graph looks like that, whenever you have the value here less than 1, we end up with decay. And whenever this value here is greater than 1, we have growth. And we're going to do some examples showing this right now. Okay. So when I'm doing exponential growth, we're going to be using this equation here, where y equals a times 1 plus r to the power of t. Now r is my rate of growth, okay? And and then y is equal to the value it's going to be, a is its initial value, and t is the time that we've got. So let's look at this example here. You purchase an antique for $2,900, and it's increasing at a rate of 9%. So the first thing you need to do is think of this 9% as a decimal is 0.09. It's very, very important to remember this, okay? Because this is going to, if you don't remember that 9% is 0.09, then your calculations are not going to be accurate or correct. Okay, so using this, the initial value, from looking at this, you know your initial value is 2,900. Your rate, for this value, we're going to put in 0.9, and let's do this. So the function represents the value of this after t years. So you can say y equals 2,900 times 1 plus 0.09. So it's going to be 1.09 to the power of t. Okay, and that's what you have to do. And then to find the value of the antique after 8 years, well, guess what? We're going to replace the t here with 8. So let's do that. So I end up with y equals 2,900 times 1.09 to the power of 8. And I'll type that into my calculator. 2,900 parentheses 1.09 close parentheses caret to the power of 8. Enter, and we know the value is going to be equal to 5,778.43 cents. Let's put a dollar sign there, right? Okay, now we know we're correct if it's increasing. Is this value increasing? Yes. Okay. Now, what happens if the problem changed? Okay. So it turns out that no one likes your antique, and instead of increasing in value, it's losing 5% value because they really don't like this antique. So if I'm looking at my previous example, if the antique is growing in price, we're adding a value. Now, if it's decreasing in value, then we're going to subtract this percentage. Now, remember, how do I write 5% as a decimal? We write it as 0.05, and using this equation, we're going to subtract 0.05 because it's decreasing in value. Okay, so now we've got y equals, and the initial price was this, $2,900, right? And I've got 1 minus 0.05 to the power of t. Okay, well, what is 1 minus 0.05? That's equal to 0.95, right? So we can simplify this to y equals 2,900 times 0.95 to the power of t. And what we learned at the very beginning when we started this is if this number is less than 1, then we end up with decay. Okay, so here's our equation. Our antique is losing value, so for decay, what is it worth after 8 years? So we're going to replace the t here with 8. So we get y equals 2,900 times 0.95 to the power of 8. And let's type that into my calculator. If I hit second enter, that gives me the entry that we had here before. Now I want to go back here and change this value, right? So I can hit delete, 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 and then second insert, and it's 0.95, right? 0.95 to the power of 8, and my new value is $1923.92. Okay, and let's see, does this make any sense? If it's losing 5% of value, then it should be a number smaller than 2,900, and this is a value smaller than 2,900. You need to check to see if your answer makes sense. Okay, let's do one more example. Okay, so you've got 300 grams of carbon-11, and it's got a half-life of 20 minutes. Write an equation to do this. Okay, so remember, we were using y equals a times 1 plus r to the power of t. Now, think about it for a second. If it's got a half-life, that means it's getting smaller, and the rate is 50%. Okay, well, how do I do 50% as a decimal? The rate is 0.5. Okay, now since it's decreasing in value, we're going to have minus that. So we have y equals a times 1 minus 0.5 to the power of t. And so we've got y equals a times 0.5, and then now since it decreases in 20 minutes, then we have to say that this power here is going to be, after 20 minutes, it's lost half of its size. So this power here is going to be n over 20, because if you think about it, when n is 20, it's now half the size. So we multiply the initial value times 0.5. Now our initial value is 300, so our equation is going to be y equals 300 times 0.5 to the power of n over 20. That's the power. So you may want to rewind this and play it again if you have trouble with this. Okay, so because it loses half its life every 20 minutes. The power has to be n over 20. Now, how much carbon 11 is going to be left after 3 hours? So, first of all, how many minutes are in 3 hours? So we can say 3 hours, we know in 1 hour there is 60 minutes, right? So if I do this calculation, we end up with 3 times 60, which gives me 180 minutes, right? So we know the time that we're dealing with is 180 minutes. Okay, so let's look at our equation. We've got y equals 300 times 0.5, and to the power is, my power is 180 over 20. Now 180 over 20 is going to give me 9. So my power is to the 9th power. So we've got y equals 300 times 0.5 to the power of 9. Okay, so then I can type this into my calculator. 300 times 0.5 to the power of 9, and we get y equals 0.5859, and that is the amount of grams left over. Okay, so it's decreased in value. It's in half 9 times. All right. If you have trouble, you may want to watch this video over again to help you.